Alrighty, we're back for this 97 Dodge Grand Caravan. I made part 1 on this, where the wipers would intermittently go off and the instrument cluster would intermittently not work. Well, right now, the wipers, you can see they're kind of in a different spot, but the cluster's not working, service engine light's on. And I did a full system scan with the adapter there. I don't think I can talk to the PCM, I can't talk to the BCM, ABS, all those other modules. Go to report. No CCD bus on the PCM. PCI message from the BCM. So, I'm scoping this again. You'd have to watch part 1. Well, I'll explain it again in this video how the CCD bus works. Basically, it's module to module communication, Chrysler collision detection. It's not, you know, like a crash for an airbag or nothing. It's collisions of information. It's module to module communication. And you don't have to have the scan tool hooked up to talk to or to see activity on the bus. What we're seeing here, these long traces are wrong, and they're long. That's your message there. Let me go over that here in a minute. All right, so let me go over this. I might have misspoke a little bit earlier, but positive is going to be in pin 3, black is going to be in pin 11. Again, I'm using 1 channel, and it's module to module communication. You do not need a scan tool hooked up to see this. But what you're looking at, if you start at, look at that, that's the waveform there. It's going to be 284 millivolts, the difference. So if I go to 1 volt, I pause it. Let me get again here. That is the waveform. It's a little low, should be 284. You have to watch part 1 of my video. That is your square wave, module communication. The issue we're having is you can see those tall peaks in there. Let me put a trigger on. That is the issue. You're getting a 0.5 volt. This should be there, that should not be there. And that's exactly why we have no communication with our instrument cluster, airbag, ABS, and all that stuff. We have a CCD bus issue. That is the issue that we're having. Alright, so I'm going to rescan it again, only because I had to restart my scan tool. I had issues with it. But that should not be there. If I reverse the player to these, it'll just be an upside down waveform. If you do pin, well, I'll show you here. Look at that, that's bad. Look at all that hash. Or that should not be there, those tall ones. It should be down there. But if I take and put pin 3 to ground, I'm at pin 3 to ground. You do that here. You get 9.5 volts. That's not right. I don't believe. And I go pin 11 to ground. 9.5 volts. 9.5, 3 to 11 to ground, then go to 3 to ground. A little bit under 9.5, it changes because of the square wave. Alright, so I had to verify from one of my other videos, but if I take pin 3 to ground, should get, one side should be, you know, it should be around 2.5 volts. 2.51, then you go like 11 to ground, and I might have these mixed up. The other one will be 2.49 volts, a difference, right? 2 to 300 millivolts, 284 millivolts to be exact. Should be down here, but I don't have that difference. There's an issue. And I'd have to, part 1 of this video series, I don't know how long the series will be, I'll go over that in a lot more depth. Well, if I go back, red to pin 3, black to pin 11, off the schematics, which is in part 1, No, I don't have those. There they are again. Take this measurement stuff off. And no comm besides the engine computer, no CCD bus. So why are we getting these spikes? Why is our bias voltage not correct? Alrighty, so I have to go over my video to remember, and Steve here is made me a sandwich. If there's any ladies out there, Steve may be available one day. Probably not.
No.
Alright, so watch this part here. This video, this is part one of the video I did.
Let me look at some more data here.
So our waveform looked pretty good according to that video. However, I tried to go to the instrument cluster and I still have a no comm. So that bus looks good according to this video. However, it's still, we can't communicate. Now, what he's talking about here, just listen to this part.
Remember, we're looking at the whole world. We can use the voltage to minus in 11. We should get a good signal. This is what it'll look like. And the only difference is if we come up wrong, they'll be inverted. But it just messes with your mind.
Which we saw.
So what happens if this signal doesn't look good like this? What do? If the signal isn't correct at pin 3 and 11, remember, we're looking at the whole world. We can use the voltage.
Now he's just saying the check for the bus, positive 2.49 volts plus negative 2.51 volts. Well, I'm doing that right now, which I don't think we need to do, but pin 3 to ground now. Your bias voltage from the modules on the bus. I mean, he's pretty specific on his numbers, but so 2.51 right in the middle. So you can see there on part one, and I referenced that other video in part one, if you don't get the right voltage here, which we don't, across 3 and 11 for the CCD bus, because we got that big arc or high voltage there. Let's just take 3 to ground. One, you're going to get 2.51. And take 11 to ground, you're going to get 2.49. The difference of 200, 300, actually 284 millivolts to be exact. Well, we should be down here. It's not even on our scope. And if I go to a 20 volt scale, look at that. We're getting 9.5 volts. Let's go to 3 to ground. No, 11 to ground. We just did 3 to ground. Same thing, 9.5 volts. Roughly the difference. We have higher voltages on these. We should not have that. There's our issue there. Now we got to figure out what is causing this issue. All right, so we can agree that our bias voltage is incorrect. So back to this video, Dead on Diagnostics I've been referencing. This guy's got awesome videos, but watch this part again, live. Well, live for this video.
We're looking at the whole world. We can use the voltage to see if we have contact at the termination resistor. Do we have 249 on the positive bus? Do we have 251 on the minus bus? That tells us that at least we have termination resistors. And remember, only 2 modules have termination resistors. The instrument cluster and the PCM. Either one of those.
So it says if you had the correct voltage, you would have good termination resistors. Well, and in this case, and I looked this up and it shows it in part 1, PCM is a term resistor and the IPC instrument cluster is a term resistor. Our instrument cluster is not doing anything. Is that why it's affecting everything else?
We have bias. If they're both disconnected, we don't have bias. By verifying the bias, we know that at least continuity to one of the 2. We're not sure which, but we know one of those 2 are hooked up. So now we're going to have to isolate the modules. But remember, we got...
So like he just said in the video, Dead on Diagnostics, we're going to pull up the schematic again, isolate the modules, and see what we got going on. So we're going to pull up the schematics again here, and I'll have to reference my part 1, or I can pull them up because I had them all pulled up in there, and I should have printed them off, but I didn't for part 1. That was a few months ago. Been pretty busy, but Steve, can you stop bumping into me when I'm filming? Thanks. So watch this part here.
Look at each one. For this circuit to work, it must have 120 ohm termination resistor, and only the PCM and IPC terminate the circuit. We've opened it up, they're no longer terminating the circuit. So what we're going to have to do is, if everything is working, we're going to see 5 volts down on the minus volts, on the minus, with the plus going to 0. That means there's no termination. We've isolated the module.
We can check across pins 3 and 11 for term resistor, and if it's just like CAN bus, we should have 60 ohms. You put two 120 ohms in parallel, two 120 ohms in parallel, you get 60 ohms. You know, on battery unhooked and all that. Now, I'm not sure if I did that in part 1 or not, but we're going to check it here next. All right, so I got everything off. The battery's still hooked up across 3 and 11. We got 52.3 ohms, not 60. We're going to go unhook the battery next just to verify that, see what module. If I remember correctly, I don't think this had a good splice pack on this car to troubleshoot. I think we have to unhook each module individually. I'll look in the schematics and verify that. All right, so Steve's taking the negative battery cable off here. He's really good with his hands. Well, look, we got 60 ohms across the bus. So that tells us our term resistor is good. But we don't have, you know, we got a bad waveform. Our term resistor is good. Termination resistors are both good. We must have 120 and 120 because we got 60 ohms across pins 3 and 11. We have no cluster message. All right, so we took the cluster out, and of course, when we started moving it, it started working. And if you look now, hook our scope back up. Let's just go to 1 volt scale. Look at the messages, they look good. There is no high side at all. Everything's good. And then put on a 20 volt scale. It's compared to ground, 3 to ground and 11 to ground. Run 3 to ground. There's our 2.5 volts. Let's go to 11 to ground. Those are 2.5 volts. So you get 2.5 volts. That tells us everything's good right there. And our cluster came back. Let's go, my phone might die here. There's our differential voltage. No, not yet. Right there. There's our message. No high side. And slow it down. There's a couple peaks that come off of that, but that is not like it was before. Just like any bus. When the message ends, it seems like. But this is all good now. Now, let's rescan it and see what we get. Are we going to rescan it now that the instrument clutch is back online? When I turn the wipers on, they turn on, I turn them off, they turn off, but they don't go home. There's something wrong with that module or stop switch, whatever controls these. At least they're not going on or randomly going on by themselves. Which I didn't do it in this video, but I think part 1 I did catch it. Already did a full system scan. We can talk to everything again. And TCM batteries disconnected. BCM no CCD message. ABS message. Front wiper park switch circuit open. That's why it's not going back to park there earlier. And CCD communication. So I'm going to clear all these codes and rescan it. Alright, so I cleared all the codes. One in the BCM, which is the front wiper circuit open. Watch, that's why when I turn them on there, it's not going back to park. And if you look at the schematics for this wiper, because again, from part one of the video, customer complaint was the instrument cluster would do all kinds of weird stuff, or it would work or it wouldn't work. Lights would go off and the wipers would randomly go on. Well, looking at the wiper circuit, it goes through the BCM. Well, the BCM is wiper mux signal, multiplex signal, BCM in the junction block, which is part of that circuit and controls it. Well, earlier in this video, you just saw the instrument cluster wasn't working, and then it was working. Well, if it wasn't working, there's no CCD bus. It's not getting the correct bus, or it's getting a, bad, voltages, zeros and ones is all messed up from that CCD bus. Then it's going to affect other stuff on the bus. So I think what we need to do is get a new cluster. I don't think it's a pin retention in the cluster. We can validate that though. Get a new cluster, program it to it, whether it's EEPROM, flash data, whatever we got to do, and fix that open circuit in the wiper motor. And I believe that the CCD bus corruption caused from the instrument cluster is affecting everything else in the bus, hence why the wipers go off randomly. Her other complaint was, so this window works, the driver's, but the passenger doesn't go up and down. So you got to get a quote for that as well. Oh, can you see that in the film there? The lights, the mileage. Hopefully you guys can. Here, kind of focus there. Anyways, I was wiggling and tapping around back here, if I can get it on film, but I got it to like right there. It's offline and came back online. Hopefully you guys can see that. And I'm just wiggling this wire. Look, the wipers are going off now. We're not even touching anything. Pull their film up so they can see. Oh, you missed that, Steve. All right. Too bad you're not filming in another industry. You would have missed the damn money shot. So let's go back in here. Let's do in the wipers. See if you can look at that again. So I got it to move or change, and I'm wiggling the harness, but I don't think it's really the harness because I'm pushing on the circuit board. I think it's in there that's causing the issue. It's affecting the whole bus. It goes down and the wipers start going off because they just went off. I don't know if we caught that on video or not. I'm sure you guys can hear it though. See if I can do it again. Yeah, I try to move the wires. It doesn't do much. I move it on the board. It does it. Can you see that in the video, Steve? Hopefully, phone's about to die, so. Right there, it went off. It went back on. I don't know if the wipers will do it again. Let's scope that while we're doing this. All right, so now I'm going to do it again here. When I'm pushing on the connector, it's not the connector. I firmly believe it's in the circuit board where it's soldered on, because looking back now, in the winter or the summertime, it really didn't ever do it. Maybe once in a while. It's been colder out, it's worse. So if I can get this to go off, you're going to watch the scope with the scan with the camera. Well, I'll yell when I can get it to turn off the cluster. Of course, I can't get it to do it now because it's getting warmer in here. We got the heat on in the shop and I'm moving it around pretty good. It went off there. You can see, I don't know if you got, if there was much hash in there or not. Go back onto the instrument cluster here with the camera, so if you can see everything. You can only get it to do it for just a second or two, if that. Yeah, I did it there. Saw some noise on the scope there. But anyways, that's why I firmly believe the wipers went off or going on or went on by themselves because the CCD bus loses communication, and which is the part of the BCM, ABS, instrument cluster, all that. And then it causes issues and you get incorrect data, and that's why the wipers are going off. So what do we need to do to fix this van is get a new cluster or fix this one, which will fix the wipers intermittently going off. It needs a new park switch, whatever that configures of, and a new window motor on the passenger side. So that is it for this 1997 Dodge Grand Caravan. Well, I know I said it was done, but Evan here, my son, we took the cluster out, he took it apart, and when we're pushing on this, we looked, if you look really close, and I'll show you under the scope when I get back to my house, it's a cracked solder joint right there. We're going to reflow these. That cracked solder joint is a black with a green tracer. Come on, focus. Which is pin 7. This one right there. Black with a green tracer. Pin 7. Right there. Well, come up to the schematics. Instrument cluster. Pin 7, black with the green tracer is your ground. So we're going to free flow that, put it back in, make sure it's all good. Well, why would, and that's why the cluster's not working, why would I mess with the bus? Well, if you remember, one of the termination resistors is in the instrument cluster. There's a term resistor in here somewhere. So that's why. We're going to go reflow that and put it back in. Well, I know I said it was done, but Evan here, my son, we took the cluster out, he took it apart, and when we're pushing on this, we looked, if you look really close, and I'll show you under the scope when I get back to my house, it's a cracked solder joint right there. We're going to reflow these. That cracked solder joint is a black with a green tracer. Come on, focus. Which is pin 7. This one right there. Black with a green tracer. Pin 7. Right there. Well, come up to the schematics. Instrument cluster. Pin 7, black with the green tracer is your ground. So we're going to free flow that, put it back in, make sure it's all good. Well, why would, and that's why the cluster's not working, why would I mess with the bus? Well, if you remember, one of the termination resistors is in the instrument cluster. There's a term resistor in here somewhere. So that's why. We're going to go reflow that and put it back in. Alright, so we're going to go ahead and solder this. So I'm on the microscope here and you can see good cracked. So we're going to go ahead and reflow that and put it back in. So you can see it's cracked pretty good there. All the way around it. Alright, well, we fixed it, right, buddy? We soldered it. Now we're going to go put it back in the car and make sure everything's good to go. Alright, so Evan's putting the cluster back in. Right, buddy? Or Steve-o. Put it back in and we'll hook it back up. And then we'll make sure everything's good to go as far as that part of the van. Alright, clutcher's back in and moving it around the lot. Nothing acted up. It was solid the whole time. The wipers are off. If I turn them on, they work just fine. We got to fix that park switch there because there's a code for that, like we said. But I can turn them off. They stay off. See that? They stay off every time. So that's all good. So that cracked solder joint ground was causing bus issues because IPC is one of the termination resistors. Whatever's happening internal in the circuitry there is causing issues. The instrument clutcher is good now. The wipers aren't staying on by themselves. We'll put all this back together, and that'll be it for this 1997 Dodge Grand Caravan. CCD bus issues.